Students, welcome to my YouTube channel. In this video lecture, we are going to answer questions from sample paper number 7, BALI navigation book. In my previous video lecture, I solved the first 60 questions. In this video lecture, I am going to answer the next 10 questions, question 61 to question 70. So, 61. Simple. The period of validity of the navigational database in flight management computer is how long? So the period of validity is what? 7 days, 28 days. 28 days depends upon operational requirement. So the correct answer here is option Bravo. The period of validity of the navigational database in the FMC flight management computer is 28 days. 62. The FMC navigational database can be accessed by the pilots for what purpose? To read information, to update the database, to change information once every 28 days. So the correct answer here is option alpha. Pilots can only read the navigational database, can read the data which is in the flight management computer. The changing data, amending the data, updating the data. Okay, all these jobs, all this work is done by somebody else, not by the pilots. Pilots can only get access to the navigational database for the purpose of reading it, uh, to know some information, to find out some information, something like that. But any other job like updating it, changing it, will be done by engineers. Next. A landing compass is used to establish aircraft magnetic heading during a compass swing. Is the compass used as a reference during landing? Is a compass on which compass direction for landing may be set. So we all know correct answer is option alpha, compass swing. The compass swing is the process in which we bring compass heading close to or make compass heading as much as possible equal to magnetic heading. Now we all know that there is a magnetic compass. Now a magnetic compass inside your aircraft will behave completely different from a magnetic compass outside your aircraft. Let's say a magnetic compass outside your aircraft. So this is your aircraft. Okay. There is a magnetic compass in this aircraft. There is a magnetic compass outside this aircraft. Now, let's say a magnetic compass outside this aircraft points to a direction of 090. Okay. Now, the same magnetic compass, when you take inside the aircraft, it will point at some other direction 087, 088, 092, whatever. So, let's say it points at 093. So, this difference that happens when you take magnetic compass from outside aircraft and place it inside aircraft is called deviation. So over here deviation is 3 degree west. Deviation west compass will be best, meaning the heading shown by your compass in your aircraft, which is 93, is more than the heading shown by the magnetic compass outside your aircraft. So we say magnetic heading is 090 in case of this magnetic compass. We say compass heading CH is 093 in case of magnetic compass in your aircraft. The difference between them is deviation. It's 3 degree west because compass heading is more than magnetic heading. Okay, now why does this happen? This happens because your aircraft has electrical influences, or the electrical influences in your aircraft will affect the magnetic compass reading. Okay, so if it reads 090 outside, when you take the same compass in your aircraft, it will get influenced, affected by local electrical influences, and, the resultant heading shown will be completely different from the real or the correct magnetic heading. So compass swing, next compass swinging is the procedure that closes this gap or this difference between a compass heading and magnetic heading. If it's not able to completely eliminate this gap or this deviation error, it can at least minimize that error as much as possible. So that is the purpose of procedure of compass heading, compass swinging. So correction. Now, in order for this compass swinging to happen, we need two compasses. One is the compass in your aircraft, and another is a compass called landing compass. Now, this landing compass is a reference compass. It's a reference compass, and we consider this reference compass to be perfect. So first what they do is they will check the heading shown by this landing compass or reference compass. For example, if it shows 090 landing compass, and then they will check the same correction. Excuse me. If they show the they will check the same heading shown by your compass in aircraft. So if the compass in your aircraft shows a heading of 093 like here, so they will note the difference, that the difference between the heading shown by your original compass, the reference compass, the landing compass, and the heading shown by aircraft compass. And then they will do the compass swinging process. Okay, and through that compass swinging process, they will try to bring this difference between them to a close, okay, or to close that difference as much as possible. So the correct answer here is option A, is used to establish aircraft magnetic heading during a compass swing. So finally, when compass swinging procedure happens or is completed successfully, they will attach a compass card in your aircraft below your magnetic compass, and it will be written on the card. If you want to fly a heading of north, okay, you must fly a heading of 359. Okay, so if you want to fly a northerly track, okay, if you want to go from point A to point B on a northerly track, so in your aircraft you will be flying a heading of 359. Now every aircraft will have a different compass swing procedure, will have a different compass card, because every aircraft will be subject to different electrical influences. So if you want to fly from point A to point B in this particular aircraft, it will be written on that compass card. Follow a heading of 359. When you follow that heading of 359er, you will end up flying a course of 360, and you will reach your point B destination successfully. So flying a heading of 359er is equal to a flying a heading or course of uh, 360 in this particular aircraft. This is what they're trying to say in calm air, in still air. Similarly, if you want to fly a heading of 030, fly a heading of 031. Okay, so this way a compass card will be attached, and you will have to, and the errors are very little, so 1 degree error, 2 degree error, but still the compass card is there. You must pay attention to that compass card, and whenever you are flying your flight plan, your cross country flight plan, you want to go from alpha to bravo, point A to point B, you must consider that compass card in your calculations and adjust your final compass headings accordingly. Okay. Next, 64. What is expected approach time? Now there are two types of time, EAT, expected arrival estimated. There is ETA, estimated time of arrival, ETA, and this is EAT, expected approach time. So very important for your Viva exams, airline interview, ATPL. The expected approach time is that time at which ATC expects arriving aircraft to leave the holding fix to complete its approach for a landing. So expected approach time is the time expected, is the expected time where when you will come out of your, or you will exit your holding pattern and begin your approach for the landing. Okay, so the actual time of leaving the holding fix will be dependent upon your approach clearance. Okay, so expected approach time is just an estimate, is just an idea into the future. So time at which ATC expects, okay, ATC expects that an arriving aircraft following a delay will leave the holding pattern to complete its approach for a landing. Simple, so estimated time overhead the destination overfield wrong. Estimated time to leave holding fix following a delay, yes. Estimated time, estimated final approach fix time. So that is wrong. 65. Aircraft plans to depart London at 12 o'clock UTC time and arrive at Munich. Airport code is Echo Delta Delta Mike at 1215 UTC. In ATC flight plan, item 16 should be entered what? So this is your ATC flight plan. And here is your item number 16. Destination aerodrome. There is a box for destination aerodrome. Second box, total estimated elapsed time in hours and minutes. Next, alternate aerodrome box and second alternate aerodrome box. Okay. So You will have to enter total estimated elapsed time. So the time starting from point A to point B, where your flight plan ends. So aircraft plans to depart at 10 o'clock. So starting time is 10 and arrive at Munich at 12:15. So ending time is 1215. So total estimated elapsed time. Elapsed means time spent from point A to point B is how much? 0215. 2 hours 15 minutes will be your flight estimated elapsed time. So you are going to enter in item number 18 that estimated elapsed time, which is correction item number 16, estimated elapsed time of 0215. 0215. Charlie. Okay. Next. An aeroplane is flying from an airport to another airport. In cruise, calibrated airspeed is so and so. Okay, calibrated airspeed is 150 knots. Through airspeed is 180 knots. Ground speed is 210 knots. Now, out of these three speeds, what speed are you going to enter in your flight plan and how will you enter it? In what form? So, you can check here. Item number 15, cruising speed. Okay, so you are going to enter cruise speed and that speed will be in terms of true airspeed. Cruising speed in terms of true airspeed. This is what you are going to enter in your flight plan. Do not enter calibrated airspeed. Do not enter indicated airspeed. Don't enter ground speed. The speed that you are going to enter is true airspeed. And how will you enter it? Now here the speed is 180 knots. True airspeed 180 knots. So the correct form is November. Okay, it's 180 knots, right? For knots, the letter is November. For kilometer per hour, it is kilo. Okay, so it's not. So first letter N, November, then 0, then 180. So this is the right way. So you are going to select an option which has this answer. Okay, that's cruising speed, November 0180. Important. Next, which of the following isn't an advantage? Read the question carefully. Of a slotted and if you open your Oxford Radio Navigation book, page number 60, you will have this page. Phased array antenna, which is also known as slotted antenna, and this particular antenna has following advantages. It has a narrow beam width, it has reduced side lobes, less power required for a particular range, narrow pulses, improved resolution. Improved resolution. So, hence the advantages of a slotted antenna over parabolic reflector are so and so. Which one of the following isn't an advantage? Reduced side lobes, yes. Directivity, yes. Directivity is nothing but narrow beam width. Okay, so comparatively, option Charlie is the right answer. Improved resolution is not an advantage of a slotted antenna. So select option Charlie. Now it's given here improved resolution is also an advantage, but narrow beam width, reduced side lobes, narrower pulses are more advantageous than improved resolution. Okay, next. 68. A VOR and DME are co-located. You want to identify DME by listening to the call sign. Having heard the same call sign 4 times in 30 seconds, what happens? Now, when VOR and DME co-located, you will hear there will be 4 call signs will be given out 4 times. 1, 2, 3, 4. So first 3 times you will hear the call sign for the VOR station. VOR first 10 seconds, again VOR, next 10 seconds, third time VOR, again 10 seconds. And the fourth time they will play the call sign of a DME station, of that particular DME station. So that will happen at the next 10 seconds. So at the last 40th second, we will hear the DME call sign. And this DME call sign will be the one with the higher pitch tone. Higher pitch tone. So very important. Okay. So VOR and DME call signs were the same and broadcast with the same pitch. Wrong. DME call sign is the one with the lower pitch. Wrong. DME call sign is the one with higher pitch. Yes. And it is broadcasted only once. Yes. VOR station broadcasted thrice. DME station once. So option Charlie will be the right answer. Question 69. A radio altimeter can be defined as a self-contained onboard instrument, self-contained onboard. Okay, so first part of all the three statements is right. Used to measure density altitude of aircraft, used to measure true height of aircraft, used to measure pressure altitude of aircraft. So correct answer is option Bravo. A radio altimeter is that instrument which gives you the height of aircraft below the ground. Correction, height of aircraft above the ground. Okay, so direct height of aircraft above the ground. So that is what radio altimeter does. It works on the principle of continuous wave transmission. The transmissions are frequency modulated. Radio altimeter works in the frequency band of super high frequency between 4.2 gigahertz to 4.4 gigahertz. Okay. Now, density altitude cannot be shown by any instrument. Density altitude is calculated manually before you start your flight for your departure airport, for your destination airport. Pressure altitude. Now, pressure altitude can be shown by a sensitive pressure altimeter if you insert or enter standard pressure setting in the altimeter pressure setting window. Pressure altitude can also be provided is also provided by a mode C capability transponder to the APC controller. Okay, so option Bravo is the right answer. Now, radio altimeter can give you the information of your height above the ground. Similarly, your pressure altimeter, when you put QFE aerodrome pressure setting in the pressure setting window, it can also give you the height information of your aircraft. Okay, next. In south hemisphere, you are landing in westerly direction. What will happen to magnetic compass? Now your magnetic compass is subject to two types of errors: acceleration and deceleration error, and the second error is turning error. So now this question pertains to acceleration deceleration error. Now you are in the south hemisphere. So let's consider this is your northern hemisphere, this is your southern hemisphere. Okay, so north pole, south pole, west, east. You are landing in the westerly direction. That means runway is oriented 0927. So you are landing in the westerly direction like this. Now when you are landing, what happens to the forward speed of your aircraft? The speed of aircraft continuously decelerates or reduces, right? So that's why this magnetic compass will be subject to acceleration deceleration error. Now what happens? You are in the southern hemisphere. Condition number one, you are in the south hemisphere. Condition number two, you are flying a westerly direction. Condition number three, you are decelerating. So what will be the final output? When you are decelerating in the southern hemisphere on a westerly heading, the magnetic compass will erroneously or will wrongly show an apparent turn. Apparent turn means false turn. Not okay. It's not the real turn, but a false turn towards the north, towards the north pole. So you're landing in westerly direction. Okay, your aircraft is oriented 270 with a heading of track of 270. So you expect your magnetic compass to show that same direction 270. But since you are decelerating your aircraft, you are decreasing speed of your aircraft over the period of time, the magnetic compass will show an apparent turn towards the north pole. Okay, you are not turning towards the north, but still magnetic compass will falsely show a wrong turn towards the north pole. If you're flying in the westerly direction in the southern hemisphere and you accelerate your aircraft, such as in a takeoff roll, okay, you want to start your takeoff run. In that case, aircraft magnetic compass will show an apparent turn towards the south pole. Okay, so it's very important the hemisphere you are in, the direction you are flying, and the mode of flight, the phase, whether you are in a deceleration phase, an acceleration phase, whatever. So over here you are decelerating. So all these three conditions will have a final result that your aircraft shows an apparent turn, a false turn towards the North Pole. Okay. So an apparent turn towards south, no apparent turn towards north. So option Charlie is the right answer. Very important question. So this concludes our lecture. I hope you have understood all the questions that I have answered in this video lecture. If you have any questions, let me know. I request you all to share this video lecture with your friends who are also preparing for the exams. Subscribe if you haven't yet and press the like button if you have liked this video lecture. See you in the next video in which I will solve the next 10 questions.